Everyone, today we're going to be talking about our skin cancer detection app called Onclarity. Yeah, let's go to the next slide. So yeah, today we're going to be talking about our skin cancer detection app. But first, we're just going to dive into our motivation and our beliefs and like why did we decide to create a health detection app or like healthcare app. And then we're going to dive into a data set and then training, a little demo, and then deployment, and finally our takeaways from this project. Yeah, so we had a few observations, right? There were like theoretical benchmarks in medical deep learning applications. A lot of researchers spent lots of time benchmarking through state-of-the-art architecture. There's a lot of investments in medical startups, especially now. But at the same time, we don't see much disruption or modernization in healthcare. And especially with the pandemic that hit so hard, it became a painful truth about, the ever-growing inequality between healthcare providers in the United States or even in the world. So we really wanted to create an impact by creating medical deep learning applications that can close the inequality gap by providing cheap but accurate tools to doctors from all over the world. And we also want to allow those providers to focus on personalized care instead of having to worry about certain diseases or like diagnosing someone, and also promote early detection in the general public. Yeah, and that's why we proposed the public skin cancer detection model. So we used a HAM 10,000 data set. Ironically, it contains 10,015 images. It has 7 different skin cancers, and the distribution is shown on the right side. As we can see that the melanocytic nevi are outnumbering all the other diseases. BKL stands for benign keratosis, and melanoma, they are like on the second place, and the other diseases are way less prevalent. The segmentation maps were provided to us, and we converted them into bounding boxes. The diagnoses are they are like determined based on medical consensus, so they are really verified. It's a really small data set. There's no examples of healthy skin, and a trained validation and test proportion 70, 15, and 15. Next slide. So we used the faster RCNN model. It's really traditional, but we did add some novelties. For example, we used a ResNet 50 instead of like VGG. We used a feature pyramid network that evaluates pictures at a different scale. And we pre-trained on MS Coco, and we used the M optimizer. And we also did a hyperparameter sweep. We used the Bayesian sampling, and the learning rate was between 0.1 and 0.0001. Batch size 8, 16, and 32. And we used the hyperband early determination. So you can see on the right side, these are our sweeps, and we had a final test MAP of around 82%, which is really, really good. Yeah.
All right, so now we'll go into a quick demo of the actual app. So here's our web app deployed on Heroku, deep learning for skin cancer detection. We have a bit of a preamble description based on what Kevin had just talked about our motivation for why we were doing this. Then we have a little description about the actual data set and the distribution that Kevin also mentioned. And finally, over here, we have an example of the model at work. We've input an example of someone's skin, and we see the output is that the model classifies it as NV, which is melanocytic nevi, at 85% confidence. It also outputs the bounding box, and users can say either correct or incorrect for what they think. This is accurate prediction. So returning to the slides, let's now talk about development a little bit. So this was built with a Flask backend in order to handle all the different HTTP requests. And we used something called Gradio, which is a great new library for helping with creating user interfaces, specifically for machine learning models. Here you can see an example of what we just had, where it's really easy, a really simple interface where you can just input something and pass it to a model. In terms of front-end dev, we had a pretty simple vanilla design. We started with React, but due to some difficulties, we ended up just going with raw HTML, CSS, and JavaScript. In terms of deployments, we needed to get our model weights online, so we used GitHub release. Basically, we made a release of our repo, and it let us bypass the 100 megabyte file limit. To actually do hosting, we first tried Render. We had some issues with that, but we ended up using Heroku, and it was much easier to debug, and we were able to deploy our app, as you just saw. And finally, a kind of quick reflection. As Kevin mentioned earlier, we had this data set of 10,000 images, but despite that, you saw that the distribution was very different for each disease. So like, for example, some there were like 7,000 examples, some there were maybe like less than 100. So that definitely affects how well our model can learn for perhaps those more rare conditions. Also, debugging really sucks and also sucks up a lot of time. We spent so much time having to piece together all these APIs and libraries. And that's something to really take into consideration when making this kind of stuff. Another thing is, scale really matters. Figuring out how to get things from local to the cloud and the web. There are definitely a lot of considerations we have to take into account, like, how much RAM, how much compute do we have? And finally, just kind of going back to democratizing health, the fact that we were able to pull this off in just a few months is really encouraging to show that, even though there isn't a lot of change too much in healthcare medicine, just like a couple of students are able to do something like this and really, put out tools and information that can be really useful to people and help people who don't necessarily have access to a lot of resources. And yeah, that's the end of our presentation. And thank you, everyone.